I'm not going to start lateral torsion and buckling until tomorrow morning, because last thing in the afternoon, really, lateral torsion and buckling is no good. So I would like you to go to page 144, please, in your workbook. Page 144. We're missing a couple of presentations, which I will do first thing tomorrow morning. So page 144, this is the specification of a steel subgrade. And in this guide, you would need to be around page 30. We are specifying a steel subgrade, ladies and gentlemen, because we wish to avoid brittle fracture. I think this is a very important subject. I think it is very important that the structural designer specifies the steel subgrade. I do not think that it is the job of the steel fabricator to select the steel subgrade for you. It is the designer's responsibility to choose a steel subgrade. The more tension you have, the more likely brittle fracture is. The colder it is, the more likely brittle fracture is. The more stress raisers you have, the more likely brittle fracture is. So the more of these things that you have, you will need a tougher and tougher steel. And you do that by specifying a steel subgrade. The toughness of the steel is measured by the Sharpie value. Do people in the audience, are you familiar with the term Sharpie value? Yes, okay. Some people call it the Sharpie value, some people call it the Sharpie V-notch test. You take a sample of material, you machine a V-shaped notch into it, and at a given temperature, you allow a pendulum to swing into the sample and break the sample. So at this height, the pendulum has a certain amount of energy. It swings through, breaks the sample, follows through to some other height, and the difference in height is the energy which has been absorbed in breaking the sample. So energy is measured in joules, and the Sharpie value then is a measurement in joules. And that takes place at a given temperature. So the steel subgrade is a measure of the Sharpie value, and that's a reflection of the toughness of the steel. So normally the steel specifications, they call for at least 27 joules at a certain test temperature. So, for example, the subgrade designation JR means that your steel will achieve at least 27 joules at room temperature. J0 means at least 27 joules at 0 degrees. J2 means at least 27 joules at -20. So if you can achieve that sort of energy at lower and lower temperatures, it's an indicator of a tougher and tougher steel. And you will need a tougher steel if brittle fracture is likely. So, we have flipped into a different part of the Eurocode, 1993-110. That covers the choice of steel subgrade. And in the UK, we do not like 1993-110. We think it is very, very complicated. So in the UK, we have produced a document which we think is simple to apply. The rest of Europe, they seem to think 1993 110 is okay. For us, it is very complicated. Here is a helpful publication. From ECCS, the European Coal, I think. European Coal and Steel, something like that. It's helpful because it gives you some background and it also gives you some flowcharts. Now in the UK we would find these flowcharts very useful because we find the core Eurocode very, very complicated. So if you look on page 30 of this guide, that's the important table which has been extracted out of 1993 110. The first thing to note is at the top of the table there is something called a reference temperature, and the reference temperature is not the real temperature. The reference temperature is the real temperature, but then perhaps it has been shifted lower because you have stress raisers. Perhaps it has been shifted lower because you have a high strain rate. Perhaps it has been shifted lower because you are going to cold form the material. So within the Eurocode, for each one of those sorts of operations, the Eurocode says, well, that's equivalent to moving minus 10 degrees or minus 20 degrees. So the reference temperature is the real temperature, but potentially you've moved it colder and colder to allow for these other effects. And then there is a state of stress, and you can see that's delivered in terms of a proportion of yield. So is it 75% of yield? Is it 50% of yield? Off the screen, is it 25% of yield? And you see those on page 30. So we need to work out our stress and compare it with the yield strength. Once we know our stress, once we know the reference temperature, then the body of the table is simply limiting thicknesses. So these would be the maximum thickness we are allowed in a particular grade of steel. So within any particular grade of steel, as you go down the table, that reflects an increasingly tough steel. So for example, if we were in this particular column, JR, maximum temperature maximum thickness 25 millimeters. J0, maximum thickness 35 millimeters. J2, maximum thickness 50 millimeters. So the more capable steel is reflected with an increased thickness. So first of all, you need a reference temperature. So the real temperature, and then perhaps adjusted because you have stress raisers or a high strain rate or cold forming. Then we need a state of stress. The state of stress is calculated in accordance with this expression. So this means the design effect. The design effect is first of all due to the action of temperature. Now that in the UK would again be very strange. That would be if you have erected some steelwork on a cold day and you are worried about what happens when the heat increases. Or if you've erected steelwork in the summer and you are worried about the change in temperature. Are you going to build in stresses into your structure? In the UK, most of the time, we would assume that to be zero, because we think we have bolts in clearance holes that allow a bit of movement, we have bracing in the right places, and therefore we tend not to worry about the effect of the change of temperature. If we were building a stadium for a football club or something like that, we would worry about it, but for ordinary buildings, we don't. And then, I hope this arrangement now is quite familiar to you, because we have the permanent actions, but no gamma factor, so they are the unfactored permanent actions. We have a leading variable action, no gamma factor, but there is a psi1 factor, and any other variable actions, no gamma factor, but now there is a psi2 factor. So if you remember from this morning, you must be careful to look in the national annex to determine psi2 and psi1 for their type of load, because those psi values belong to a certain type of load. So when you go through that calculation, you can calculate the state of stress, and then you reflect on what the state of stress is as a proportion of yield. In my experience, the value of 0.3 is about right. In the calculations I have done, using that expression, and then comparing the stress that I get from this expression to yield, I find that 0.3 is a reasonable value. I generally conclude no more than 0.3. So then, you could enter this table. You perhaps know the state of stress, somewhere between 0.5 and 0.25. We do need a reference temperature at the top. So how cold does it get in the Ukraine? I did not have your national annex for this part, so I could not find out if the national annex says anything. So I went on the internet, and I find that in the Ukraine it might get to -20. But then I found another website, and that said -33. Ladies and gentlemen, you will know, maybe your national annex has some data. I have assumed for this example that maybe the coldest temperature is -35. You will know better than me. And then I have reduced that by 5 degrees for a radiation loss, so my reference temperature is -40. So then I need to calculate the state of stress. And for this example, I have imagined a fully restrained beam. I have imagined that the fully restrained beam is working quite hard. So the ultimate stress is 85% of yield. Perhaps it has been governed by deflection, and that's why it's only working at 85% of yield. If I was working for a steelwork fabricator, I would like it to work at 99.9% of yield. But maybe 85% is okay. So the ultimate stress might be 200 newtons per square millimetre. But I want to know what the stress due to the permanent actions is, and what the stress due to the variable actions is. So I've made a guess, and I have imagined that the variable action is 1.4 times the permanent action. It's just a guess. You would need to know what those proportions are. So I can then work out what the stress due to the permanent actions are and the stress due to the variable actions. Remember, this is unfactored, because a few slides earlier on I tried to make the point that the calculation concerns unfactored stresses. So I want unfactored stresses. I need a psi value, so I've gone back to the Ukraine National Annex, and for the sort of load that I have in my mind, psi1 is 0.5. So okay, I can now work out the state of stress, and it's the stress due to the permanent actions, in this case 63, plus psi1 multiplied by the stress due to the variable action, in this case 88. So it gives me 107. So what proportion of the yield strength is 107? 0.45. But the table doesn't include 0.45, so I've been conservative and I've decided to use 0.5. So here's an extract from the table. Minus 40 degrees, I'm assuming. State of stress, conservatively 0.5. So my limiting thicknesses are for S235JR is 40 mil, or for J0 is 55, or for J2 is 75. Now, of course, you will have chosen some steel sizes. You will have a thickness of the flange, for example, and you will therefore need to decide whether JR is okay, or whether you need a tougher steel, or perhaps even a tougher steel. Because you don't choose the steel subgrade and then select plate. You select plate and then decide the steel subgrade that you need. So my observation, I cannot tell whether in the Ukraine you generally do choose the steel subgrade, but to me it's a very important part of the designer's responsibility. So now, ladies and gentlemen, I have finished for the day. I would be happy to answer questions if you have them. I believe there is a microphone.
Maybe it is just a general question. Maybe it's better to ask it tomorrow, but still. We're now in the process of implementation new codes, yeah?
Yeah.
Still we're having our old, not former, they're still, they have power, yeah? And the new one, they are having power too. So the general question is, how will it work? I definitely understand that you don't know that, but I want just to hear your prediction for this, according to your experience, as it was in GB. As far as I know, English Great Britain standards is called BS, yeah, British standards. When was the Eurocodes implemented? How was it? How the market reacts? How?
Yeah. Okay. A good question. The British standards were withdrawn in 2010, and everybody carried on designing to the British standard, for sure. Probably 3 years ago, people started to change to the Eurocodes. The change started with the major designers, so people who perhaps had some international business as well as national business. Companies that had large offices. So the major companies have certainly changed to the Eurocodes now. In my view, it has taken 3 or 4 years to get half of the UK designing to the Eurocodes. Smaller companies, I don't think that they will ever change. They will still design to 5950.
Just to be sure about this process, for deeper understanding, the British standard, they are withdrawn, yeah, but do they have power now? I mean, do you have in GB such as expertise or what? For example, if you have a design, a project, it should be registered
No. You don't, there are no requirements for registration to be able to design. So effectively anybody in the UK could design.
Okay.
You were asking about the status of the British standards.
Yeah, the actual status, could I use them now?
You can still use them for design in the UK because the UK requirement is very, very short. It says you must produce a safe structure. That's it. It then gives you a list of standards that you might use to demonstrate that you have produced a safe structure. But it says very clearly you have no obligation to use these standards. There may well be other ways to fulfill the requirements of producing a safe structure. So technically in the UK, you could use the British standards which have been withdrawn. You could use a British standard from 1940 to design steel, if you wished. You could use the Russian standard. There are practical difficulties because somebody will be forced to check the calculations, perhaps an independent company. And if I submitted something to the Russian standard, they could not check it. So there are probably commercial reasons why I would use the British standard rather than somebody else's standard. But there is no legal reason in the UK why I must use the Eurocodes. But practice is changing despite that, and I guess 50% is now to the Eurocodes. The other thing which is changing is that all undergraduate training at universities is now to the Eurocodes. So the people joining the industry, they know the Eurocodes. So they wish to design to the Eurocodes because that's what they have been taught.
One more thing to make the right conclusion about all this situation in GB. Were they united? I mean, the contractors and the design organizations, or did they move separately during this process of implementation? I mean, if you understand what I mean, I will
yes, yes. If the question is, did different companies change at different times?
Yeah, but the main idea is the contractors. It's where they.
Well, the contractors.
Did they feel the interest?
No, the contractors did not want to change.
Okay.
They did not want to change. They were very, very angry about the whole idea of change. The steelwork fabricators. They just wanted to carry on doing what they've been doing. But they have started to receive designs to the Eurocode, where the specification says, I have designed this to the Eurocode, I want you to provide connections to the Eurocode. And so they have been forced to change.
Thank you.
In truth, and we will see this tomorrow, there is very little difference for the steelwork contractor because the connections are the same as they have always been. But I think it was just a reluctance. This is something new. We do not want to be interested. Many, I would say all of the steelwork contractors in the UK, the major steelwork contractors, would now be happy to say, we can design to the Eurocodes. It's a commercial pressure. They are being asked to design to the Eurocodes, and they'll say, yes, of course we can.
Thank you.
David, I will shortly answer colleague's question.
Okay.
In Russian.
Oh, I'll listen.
По поводу правового статуса еврокодов. С 1 июля 2013 года были введены сами части ДСТУЕ. С 1 июля этого года уже введены национальные приложения полностью, и их можно применять. Касательно, как они соотносятся с нашими национальными нормами. Они действуют параллельно. Есть управляющий документ, ДПН номер, наизусть не помню, который регламентирует, что или используются еврокоды, или используются национальной нормы, что касается расчета строительных конструкций, проектирования строительных конструкций. Сами еврокоды части, они получили нумерацию ДСТУ-ЕН. ДСТУ, в принципе, это документы, которые носят не обязательный характер, если так можно выразиться, если так корректно, может кто-то поправить. Но сам вот управляющий документ, он носит, это ТБН, который уже носит обязательный характер. И им нужно руководствоваться в первую очередь, чтобы определить для себя, как двигаться. Но они взаимоисключающие. Нельзя брать нагрузки по национальным нормам, скажем, а потом считать конструкции по Еврокоду. То есть или так, или так.
Thank you. May I make one more comment? And really, sir, it's a further reply to your question. In the UK, the ultimate loads are reduced by about 8% compared to previous British standards. And as we will see tomorrow, the resistance, particularly in lateral torsion and buckling, goes up considerably. So there are commercial reasons for a steelwork fabricator to design to the Eurocodes. So if I went back into real practice, I would design to the Eurocodes because I think I have an advantage compared to the people using the previous British standard.
Do we have such compare table? Do we have such compare table?
I think I would have to ask colleagues in the Steel Construction Centre.
Да, у нас есть подобные сравнительные данные касательно приблизительно экономии по расчетному сопротивлению и расходу материалов, как следствие. Да.
Еще нету, но...
Но она однозначно будет.
Да, это будет, это все будет готовиться.
Я имею в виду экономию.
Да, ну там... Меня коллеги хочется представиться. Беляев Никита, ведущий инженер-конструктор ЦСС, Финансового центра стального строительства. Что касается, если говорить о стальных конструкциях, экономию здесь можно будет достичь благодаря еврокодам. Методика расчета еврокодов, нагрузки, в принципе, коэффициенты запаса в них больше. То есть надежность конструкции в Европе принята выше. Если у нас, скажем, обеспеченность берется 0,95, то там это берется 0,98, 0,99, где-то в этих пределах. Соответственно, надежность больше, конструкции будут, возможно, немного тяжелее. Но еврокоды позволяют применять больше типов конструкций, они более подробные. Например, в части стальных конструкций очень важны вопросы огнезащиты. У нас огнезащита выходит очень дорогая, а в еврокодах дается дифференцированный подход к расчету огнезащиты, что может ее удешевить в 2 раза.
То есть стоит понимать, что проектировать по нашему ДПН сейчас выгоднее с точки зрения металлоемкости.
Для каких зданий? Если мы говорим просто о складе, где не нужна огнезащита, и, скажем, не применять какие-то конструкции. Например, у нас вопрос, нам нужно рассчитать ЛСТК. У нас есть ДСТУ в Украине, но он очень ограничен его применение. Там толщины до 2 мм, если я не ошибаюсь. А если нам нужно применить, например, паргон холодногнутый, пролетом 10 метров, то там нужна уже 3,2 толщина, 4 толщина. В нашей ДСТУ этого нет, в Еврокоде это есть, это позволит сэкономить металл. А если мы говорим о многоэтажных зданиях, которые, в принципе, нужно развивать этот рынок в Украине, то тут сразу встает такой вопрос огнезащиты. Там расходы на огнезащиту перекрывают очень много. Позволяет получить большую экономию в целом.
May I comment on the fire protection issue, my understanding from my colleagues in the Steel Construction Centre was that even including the fire protection, the steel might be a little bit more expensive than a concrete solution. But absolute cost, ladies and gentlemen, is not the end of the matter. There is long spans, there is speedy construction, there is reduced foundations. So I wouldn't just concentrate on absolute cost. I would think about some of the advantages that a steel solution offers.